Hey, what's up everybody? Chris back with another Proto Tech Tip, and for today, we're going to quickly dive back into SolidWorks to talk about more effective ways to add clearances to your sheet metal parts. So, let's dive in. At Protocase and Protospace MFG, we revolutionize your workflow and simplify your part sourcing with the world's fastest custom manufacturing. We build your custom sheet metal and machine parts and enclosures really fast in 2 to 3 days. And everything is fully finished because we have an in-house one-stop shop for materials, components, and finishes. Now we aim to make the process of bringing your design ideas to life really simple. If you are not fully proficient in CAD modeling, you can use our in-house CAD design software, Protocase Designer, download a template from our template generator and import it into your CAD program of choice to further customize, or simply utilize our design services team. But for a lot of you, SolidWorks is going to be your program of choice to design custom parts and enclosures. So with that, today I want to show you how to properly add clearances between your sheet metal parts. But first, before we do that, we should talk high level about a couple important reasons as to why you should be adding these clearances. Adding clearances to sheet metal designs is critical for several reasons. 1. Material tolerances. Sheet metal materials expand, contract, and shift during manufacturing processes like cutting and bending. Clearances accommodate these variations, ensuring that the parts fit together properly after production. There is also typically a plus or minus 0.005 of an inch tolerance on the flat pattern once we cut it on our fiber lasers. Number 2, assembly fit. Clearances ensure that parts will assemble easily without interference. This is especially important in designs where multiple sheet metal parts need to fit together, such as tabs, notches, and slots. Without adequate clearances, parts might not fit or could cause stress or deformation. Number 3, bend tolerances. Manufacturing equipment such as press brake machines typically have a clearance on the overall flange size once we bend it. This default tolerance is around plus or minus 0.010 of an inch per bend, with all of our bends landing well within this value. However, if there are multiple bends, this tolerance can stack. It's important to take this into consideration. Number 4, finish tolerances. Lots of finishes can add tolerances to your parts. Here at Protocase, our most popular finish is powder coating, and this typically accounts for 0.003 of an inch of thickness to your parts. Number 5, ease of manufacturing. Properly designed clearances simplify the manufacturing processes. They reduce errors, ease of assembly, and ensure that the final product meets design specifications, reducing scrap and rework. So in summary, clearances are vital to ensuring that parts can be manufactured accurately, assembled easily, and perform well in its intended application. Now that's the why. Let's get into how we add these clearances inside SolidWorks. Now there are many different ways to add clearances, just like there are many different ways to design parts in SolidWorks. You can opt to do top-down design or bottom-up design. A top-down design is when you focus on the assembly level structure first and then define the overall geometry, which then drives the creation of individual parts. This typically means designing a part within the assembly and using the master assembly constraints to relate your new part to. So let's say that we want to add a bracket to this already existing U-shaped design. I'm going to first create a plane, then insert new part to this plane. Then we will start our sketch. I want the position of the bottom flange of this bracket to be 0.010 of an inch distance away from the face of the U-shape. This will ensure that with the cutting and bend tolerances, the bracket should be accurately located. So in order to do this, I'm going to apply a dimension from the bottom of the flange to the bottom of the U-shape for 0.010 of an inch. Now if we're doing bottom-up designing in SolidWorks, you're going to typically create your parts separately and then use mates to add your clearances. Now let's go get our bracket and bring it onto our assembly. I'm going to mate the bottom of this bracket 0.010 of an inch off the bottom face of the U-shape. Although there are many more ways to do this, these are the most 2 basic options to add clearances into your designs in SolidWorks. Now the takeaway here, it's best to know these design tips in advance and then put them into practice. This way you can reduce the back and forth with revisions, and we can get your design to manufacturing as quickly as possible. So if you do have any questions about an upcoming design, please don't hesitate to reach out to us at info@protocase.com or info@protospaceMFG.com, or even fill in the contact form on our website. So that's it for today's tech tip inside SolidWorks. It was a quick one, but a super important design consideration to remember. Until next time, take care.